We are going to discuss the introduction part of the compiler design subject. Coming to the compiler, compiler is a type of translator which takes a program written in a high-level programming language as input and translate into an equivalent program in a low-level language such as machine language or assembly language. The program written in high-level language is known as source program, and the program converted into low-level language is known as object or target program. Moreover, compiler traces the errors in the source program and generates the error report without compilation. After the compilation, only the program in machine language is loaded into the memory for execution for every programming language. During the execution, the target program first loaded into the main memory, then the user interact with the target program to generate the output. Compiler translate the whole source program into the target program in one step. That is, it first scans the entire input program, then translate into the target program. The target program is then executed separately for generating the output according to a given input. Why do we need a compiler? A computer cannot directly understand human-friendly programming language. The compiler acts as a bridge to convert the program into machine language. This allows the code to be executed efficiently. Let's see step-by-step example of how a compiler works. Let's take a simple program and go through the entire compilation process step by step. In this source code, first we initialize the header file #include studio.h. Within the main function, just we are printing the hello world sentence. Finally, we are written the values. This file is called source code and is saved as hello.c. However, the computer does not understand this directly. It only understands binary values, zeros and ones. In the second step, compilation process or language processing system. In this compilation process, we have different phases. First one, preprocessor, compiler, assembler, relocatable machine code, and last one, loader, linker or editor. Before seeing this diagram, we need to know the difference between high-level language and pure high-level language. If a program contains header files like #include, #define, it's high-level language, whereas pure high-level language is a program that does not contain header files. Now coming to the diagram, first high-level language is given as input to the preprocessor is converted to pure high-level language. This preprocessor remove #include file by including a file which is known as file inclusion. The preprocessor performs two functions, file inclusion and another one is macro expansion. Okay, now let us see file inclusion. So what is file inclusion? Removing #include header file and substitute another file in the source program instead of it. It is known as file inclusion. Next, macro expansion. Macro expansion means normally #define header file is used to define a constant. Let us take an example. In bank, interest rate is constant, but it may vary for different loans. In such case, if you want to change the values of interest, it is enough to change the #define file. It is not necessary to change inside the program known as macro expansion. Coming to the first phase, preprocessor handles #include file and macro #define value. It replaces #include studio.h with actual code from the studio.h file. The output is an intermediate file often called hello.i. Coming to the next phase, compilation, the compiler translates the preprocessor code hello.i into assembly language hello.s. Assembly language is still human readable but closer to machine code. Next, assembler. The assembler converts hello.s assembly code into machine code hello.o or hello.obj. This is also called object code and is in binary form. However, this is not yet a complete program. Next, relocatable machine code. Before moving to that relocatable machine code, you should know what is loader. It is a system program that places a program into memory and initiates program execution. There are two types of loader. First one is absolute loader and second one relocatable loader. Absolute loader means it loads the file into memory specified by the header file and pass the control to the program. If memory specified by the header file is currently in use, It never proceeds the execution and wait until the memory is free. Whereas relocatable loader, it stores the file anywhere in the memory, which is done by the operating system. Coming to the relocatable machine language code, act as an input for the linker and loader. Linker links the relocatable code with the library files and the relocatable objects, and loader loads the integrated code into memory for the execution. The output of the linker and loader is the equivalent machine language code for the source code. The linker combines the object file hello.o with required system library files stdio.h. The final result is an executable file, that is hello.exe in Windows or a.out in Linux or Mac OS. Coming to the third step, while we are running the program, once the executable file a.out or hello.exe is created, you can run it. In a terminal or command prompt, type .a.out in a Linux or Mac OS, or if you are using the Windows, you just type hello.exe. Then you will get the output hello world. Why is a compiler is important? Now you are understand what a compiler is. Why is compiler is important? Without a compiler, we cannot convert human readable code into machine language. A compiler optimizes the code for better performance. It helps in detecting errors before running the program. So a compiler acts like a translator that converts source code into executable program step by step. Understanding this process is essential programming languages like C, C++, and Java. I hope you all understand what a compiler is. If you have any doubts, leave a comment in the comment box and subscribe to my channel. And for more videos, press bell icon to receive notification. Thank you.